Assalamu alaikum. I am Sohan Ahmed. Today I am before to you to discuss Kepler's law about planetary motion. Kepler's law planetary motion. So let's start. Kepler's law. Kepler's law of planetary motion. Dear students, ancient Greek philosopher named one of them Ptolemy thought that Earth is the center of space, that means Sun, Moon and all other planets moving around the Earth. But the theory of Ptolemy doesn't explain many phenomenon, astronomical phenomenon. After many years, scientist Copernicus give another idea about motion of planets, keeping the sun as the center, that means sun is the center of the solar system according to the Copernicus. And many contemporary scientists like Tycho Brahe and his assistant Kepler try to collect many information about motion of planets, and scientist Kepler gives 3 laws about planetary motion. Kepler's laws of planetary motion. First law, it is another called law of, another name, law of orbit. According to the first law, all planets moves around the sun in elliptical orbit. Elliptical orbit, dear students, suppose this is a cone like structure. When you cut this cone in this way, you will get this like structure. This is a circular structure. When you cut this line, then you will see that this like structure, and this shape is called elliptical shape. When you fold this, then you will get this type of structure, and when you try to draw a center and refold, release it, then you will get this type 2 point here. This 2 point is called focus, and this is the singular form. Plural is foci. Dear students, according to Kepler, sun, all planets moves in elliptical orbit. Suppose sun in a one focus, sun, this traveling path of the planet, this path is called orbit or orbit. Okay, dear students, according to the Kepler's first law, all planets moves around the sun, keeping in sun as a focus, moves along the elliptical orbit. So this is the first law. According to the first law, so we know here all planet moves around the sun along elliptical object having the sun as one position. So this is the first law. And second law here, second law or law of area. According to the second law, the radius vector joining any planet, suppose any planet to the sun, sweeps out equal area in equal interval of time. Suppose in 1 month, it moves from A to, suppose, in B. So when it moves A to B, the radius vector sweeps out a area, that means this area. And as the planet moves along the elliptical orbit, so the distance of the planet from the sun will not be the same. That means, suppose in another time, suppose this planet are at C point, and at this point, in the time of interval of, suppose in 1 month, it moves, suppose C to D. Suppose it is at C to D in 1 month. And here the radius vector, of course, sweeps out a area, this area. Suppose this area will A1 and this area A2. According to the second law, these two area will be the same. That means in equal interval of time, the joining radius vector planet to the sun sweeps out equal area. This area will be same. This is the second law. And third law, law of period. Law of period or time period. Okay, according to this law, the orbital time period, we know that, dear students, the time period is when a body moves in a periodic motion. Time period. What is time period? To complete one cycle, suppose starting from A and completing one cycle, the required time is called time period or orbital time. Here, this is the sun here. So the orbital time period T and we know that the elliptical orbit has two axes. That means this is the major axis and we can draw two axes, and this is the minor axis. The time period, the square of the time period, according to the third law, the square of the time period directly proportional to the cube of the average distance from sun to the planet. That means average distance actually the distance of semi-major axis. Semi-major axis, that means r cube, this is the r. Dear students, so we can say that the square of the orbital period or time period directly proportional to the cube of the semi-major axis or average distance of planet from the sun. So this is the third law. From this law we can write t square, t1 square, suppose here constant k, r1 cube, suppose equation 1, and for t2 square for another planet t2 square k, here constant will be same, r2 cube. Dividing this two equation we can write t1 square is equal to t2 square, divide t1 square by t2 square is equal to r1 cube divided by r2 cube, and so on will be constant. So this is the third law. Okay, dear students, these are the three laws: first law, second law, and third law. So thank you very much. Have a nice day. Assalamu alaikum.